So on this site we've got 9 sun grows. They're each 110 kVA, so cumulatively 990 kVA. And I know the transformer, and we'll get to that. It's a 1 MVA transformer, obviously, because it needs to be above the actual cumulative capacity of the inverters. Let's move on down a little bit further. Alex, we're right in between the inverters, and we've got this kind of enclosed area here, and there's a lid, and I can see some earthing, there's a danger sign. What is accommodated, what's contained inside there?
This is a buzz duct. So this has buzz bars that connect directly back to our main switch inside the main switchboard at the end of the skid.
So this is where all the inverters basically come in?
That's correct. So each one of these circuit breakers connects directly back into the buzz duct and onto a buzz bar.
So we'll talk a little bit more about the AC isolators and the enclosures here. And I noticed too, also we've got some, I'd say that's 450 cable. I'm really bad with the width. Is that
600?
It's 600, yeah. So 600 cable tray, and accommodate on both sides of the inverter station. And you've got the, I can see, if you look closely, you can see the twin 6mm DC cable, all neatly configured. That's running in between there, and it's almost as if the one of the cable trays is being used as a lid. They're both lids, aren't they? They're just, as in...
Yeah, by facing the trays inwards, it does offer a bit more protection to the cables, which houses them securely. On a site such as this, we're not too worried about having to have that completely covered for people touching it.
Yep.
Because if you are able to get through our gates, you're inducted on the site.
Well, this is the thing. This is an authorised site. There's gates, they're locked. This site is very, very secure. No one's coming in unless you're supposed to be here.
Correct. You don't have pedestrians walking around it, potential for someone to get curious and start poking it.
Yep. Now, over here is, I can see with the black corrie, that's obviously the comms again.
Yes, that is.
So anywhere you see the black corrie, you're looking at the comms.
Not necessarily. That is split corrugated conduit. It is UV rated, and in quite a lot of circumstances it will be used to cover DC cabling.
Oh, okay, but not on this site.
On this specific site, it is only used for the data cabling.
Now, and obviously here you got the 3 phases coming out. You got your earth. It's all nice and neat, and then it's going into here. Well, and we will talk about these enclosures and these isolators, because I actually thought they were isolated, but don't say any more because we'll talk about that when we get to the other side. So moving on, I noticed this whole area, this whole inverter skid is sitting on these concrete, I suppose they're little plinths, aren't they, for want of a better word, aren't they?
Yeah, there'd be a footing. Concrete footing. Strip footings for the inverters. And the inverter skid.
Excellent. So we've got 1, 2, 3, 4 inverters on this side. Let's walk on down a little bit. Now, you mentioned with the AC cable, it's 95mm, you were saying?
Yep.
And that's XLPE. And what temperature rating? Is that 110 rated stuff? We tend to, so on a lot of our sites we tend to use.
We typically use 110.
We typically use 110 because it's less susceptible to obviously temperature derating, and in a lot of cases on long runs you can end up using a thinner cable, and also when it comes to maxing out, not in this situation, cable tray and the capacity of the cable tray to hold
Correct.
Cables. Now it's really interesting to see, back to the fusing here. Do we have fusing on the other end?
We don't.
And that's because there's no requirement.
There's no parallel out there. If we had the strings paralleled out in the field, we would put fuses out there to protect each string from the next one.
In addition to the fusing here.
Correct.
See, and that's a big thing to take into consideration if you are even contemplating paralleling to save cabling, let's say. One, you'll have to do your cable calculations again to take in the fact that there's 2 strings that are being accommodated. In this case, maybe 28 amps or so. Then you have to up the size of the cable, and you'll have to actually use some fusing and all the labour that comes with that. And this is the thing on a lot of these sites. It's not only about the materials, it's about the installation time. the personnel hours that we put into these kind of systems. So we'll move on a little bit more. And again, there's 5 inverters on the other side and there's 4 on this side, but the guys have matched it really well by whacking this enclosure here, for want of a better. Now, what it says electricity meters, Alex, what's actually going to go in there?
Well, currently this doesn't have anything inside it, but this is going to be for our generator meter monitoring, which is so the DNSP can be informed about how much production is entering their network and control that asset when need be. So it'll be interlinked back to our main switch, and if they decide that they need to offload this asset, they can remotely turn it off.
When you say offload this asset, what do you mean?
Stop production.
Okay, that's the official term. And so we're in here, what kind of metering are we talking about that's going to go in there eventually?
It will pretty much look like most meters you've seen, the MK10A EDMIs.
Yep.
Is mostly what they use, and they use the interlinking into the contact on it.
Now, is there any CTs that actually go into that enclosure?
Not in this enclosure.
Right,
this enclosure will have cabling
right.
fed through this conduit into this top chamber over here, which is the Supply Authority CT chamber.
Because in this particular geographic area of regional Victoria, we're talking power core, aren't we?
Yes.
All right, so moving a little bit more, Alex, if you'd like to move over to, say, this here, we've got this battery cabinet, and when I walked around before we started filming, I said, Alex, what's this battery cabinet? What's going on here?
This battery cabinet is for loss of mains. So if we lose power from the grid, our control gear in the SCADA section will maintain.
So this is a UPS specifically for the SCADA.
Yes, it will allow this switch to still be operated, and for us to see that there is no power on site.
Now I noticed where the AC bus duct is connecting to this section here. So we've got a combination of, well, really it's a combination of an interface protection, which is on the other side, and, well, a main switchboard. Is that all in one?